All right, everyone. I think we're going to go ahead and get started. Thank you for joining us today for our webinar. It's my pleasure to introduce Simon Howard and Ryan Matthews as our speakers, and they will be discussing access security. I also want to introduce Matt Lane. He is DataVision Senior Network Engineer. So Matt, I'll just turn it over to you and you can say a few words before we hand it over to Simon and Ryan.
Sounds great. I appreciate it, Kim. Good morning, everyone. Again, this is Matt Lane. I've been with DataVision for over 12 years, based out of Lincoln, Nebraska, a senior network engineer in which I'm 100% focused on the HPE Aruba portfolio. As many here know, we at DataVision are very vested into the success HPE Aruba has had and continues to build on in the marketplace. We've been a platinum partner with Aruba for over a decade, and I can confidently say that the acquisition of Access Security is unequivocally the most exciting acquisition to date. Without further ado, I'd like to hand this over to Simon Howard and Ryan Matthews.
Thanks, Matt. Good morning, everyone. So I'll just do a quick introduction for ourselves. I'm on the sales side, Ryan's on the my technical counterpart. And we've been together in the SSE side of things for about 4.5 years now. So we came over with the Access acquisition to Aruba, which we've now seen obviously strengthen a number of things with some of the offerings, and we'll cover some of those today between things like ClearPass and SD-WAN. But also prior to that, we were at some of the other SSE vendors as well. So we've got some experience of some of the other things that are on the market. What we're going to cover today is we're going to walk through a bit of a whiteboard scenario. I don't know if anyone saw the link that we sent out, but we're going to cover through a whiteboard scenario and really walk through some of the different things that we hear people are looking for on the market, and covering anything from, VPN replacements to how does this help with merger and acquisitions, and then going into other details around what the user experience is like, visibility and logging that you can expect from the platform and how that matches up to what you've got today, or what you are hoping to get in the future. So we're going to walk it through in a bit of a interactive way. If you've got questions along the way, please feel free to ask us as we're going. But other than that, I'll let Ryan quickly introduce himself so you know the difference between the voices, and then we'll get onto the whiteboard.
How are they not going to know the difference between the Englishman and the not Englishman? This is ridiculous, Simon. So Simon and I are partners. As he referenced, I'm the technical of the two of us. But we've worked together for over 3 years now. So, but very similar experience in terms of industry and whatnot. I'll keep it brief. Shall we get going, Simon?
Yeah, I think let's bring out the whiteboard and let's walk it through.
Apparently, screen sharing is disabled. Can we fix that, Kim?
Yes, let me just take
I'm wondering, yeah, whatever.
So you need, give me 1 second.
No worries.
So just while we're waiting for them to get that going, I think I'll cover a couple of high-level pieces. So anyone who isn't aware of what Access Atmos does, we are a cloud-based security platform which focuses on brokering traffic to internet and SaaS applications and also private applications. And so when we walk through the whiteboard today, we'll be covering aspects of both of those things and going into some details of how that would work with Atmos. And then also some of the pieces just outlining maybe how that would be working today so that we can draw the distinction between the two. So I see that we got the whiteboard up. So I think, what you're seeing today is kind of more of a future state scenario that we would go and illustrate for folks. But for the purpose of today, this is the best way, I think, for us to go about it. And so I think what the best way to do this initially would be to cover off one of the main topics that comes up for us on a regular basis to get us started here, which is how do we replace VPN? And this is something that a lot of organizations come to us with because they are looking to remove people from the network, whether that is current employees, whether it's third parties and contractors, even just people coming in to deal with the HVAC systems, whatever that might be. How do we get rid of, one, all of those VPN connections that we've got coming in? And two, how do we secure our environment better by having not having all those connections? So Ryan, do you want to walk us through on the whiteboard here how we are able to go and fully replace a VPN with Atmos?
Yeah, sure. I think a little bit of a small amount of background first. We're showing Atmos in the middle here as this box. Logically speaking, that's kind of what it is. Physically, it's a service that runs in all 4 of the major cloud providers globally. So it's not isolated to any one physical location or any one cloud provider. So it's important to kind of keep that in context as we go. But the idea here with Zero Trust Network Access and replacing VPN is that our cloud presence here is designed to broker communications between 2 parties. And we do that by first deploying this thing we call a connector inside your data center or your cloud environment. And that connector builds an outbound connection to my cloud. And the value of that, number one, is that reduces attack surface. With traditional VPN, I've got an inbound connection to my network that I need to listen for at all times, which means that one, I'm vulnerable to denial of service and other attacks inbound against my firewall, but two, that I'm now needing to ensure that I've kept that particular VPN device patched and up to date, and there's no zero-day vulnerabilities on it, et cetera. With this outbound approach, there is no attack surface. So that's number one advantage and number one kind of architectural difference. The user then would install some agent software on their computer, and they would also make an outbound connection to my cloud. And here's where the second difference comes in. With traditional VPN, once this user is connected, they would be able to see everything on the network. In essence, what a VPN does is extend this network out to this host. And what we're doing is very different. We're brokering access to specific applications. So this user here wants to create an RDP session or connect to a SQL server. They request that from us. We validate their identity against whatever identity provider you have for Azure AD, Okta, Ping, et cetera. We validate that the device is qualified to make the connection. The difference between, say, a managed and an unmanaged device can be validated at this point. And then we take a look at the policy. Is the user who's sitting at the keyboard here allowed to connect to the SQL host in the back end? And if all of that checks out, then this guy opens a connection to the SQL host on the user's behalf and sends the resulting packet to here. And then the cloud sends the resulting traffic back to the user. The advantage of this is that as far as the laptop is concerned, it's talking to the cloud. And this could be, by the way, I call it a laptop. It could be an iPad. It could be an Android device. It could be whatever. And as far as SQL is concerned, it's talking to this connector. So everything that exists between here is completely access magic. And by that, we're able to basically achieve what we call user to app segmentation. So now I'm only providing access for this user to the select apps that they have permissions based on their identity, posture, and access control. The user experience of this is also a lot better. So we're able to basically give them an always-on open your laptop and work experience where they're not authenticating 5 or 10 times a day. In terms of how we fully replace VPN, I'll make one more comment here and then I'll pass back to Simon for a minute. And that is that a lot of folks who look at these zero trust network access solutions will get 70, 80% of the way through implementing it, and then they'll realize there's some component in their data center here. Typically, it's something like patching via SCCM or voice over IP phone calls that requires the server to initiate a connection back to the user, which works fine on VPN. But with ZTNA, most of the solutions on the market only allow connections initiated by the device into the network. And so these SCCM and VoIP type connections just fail. With Access, we can have those connections be routed here to the connector, and we can initiate a new connection with the client through that process while still maintaining the full separation between these two and the access magic in the middle. Anything I missed there, Simon, that you would want to cover?
Yeah, I think a couple of things that come up is one, our ability to apply some of the security tools and protocols that you've got listed on the box on the right to private application traffic. But in addition to that is how does this affect firewalls for organizations? What do we see people typically doing there? I'll let you address both of those.
Yeah, sure. So in terms of the latter one first, because it's simpler, what we typically find is that historically this firewall, and even potentially if you've got a segmented network, you may have additional, I guess that's a bad way to draw it, you may have additional firewalls here between these segments. There's a lot of user-driven policy in these firewalls to control who or what is allowed to access certain applications. That need goes away significantly once you move your policy engine to the cloud. And that becomes a real value when we start talking about a multi-cloud environment where you've got some apps in AWS, some apps in Azure, and you're maintaining different cloud-native firewalls here, plus a physical on-prem firewall. It's a bunch of different points of management and a bunch of complexity. And so typically we see the policy management drastically reduced on these firewalls. And often you can also significantly reduce the licensing as well. And that's kind of tied to the first thing that Simon mentioned, which is our ability to actually provide security controls on privately accessed traffic. And this is a unique differentiator for us, where a lot of other technologies in this space just don't offer that capability. And what allows us to do that is the fact that for both internet security and private application access, we have one data pipeline. It's one physical path through our cloud. It doesn't really matter where the traffic is going. And so we can take these controls that would be normally applied for internet traffic, and we can apply them on private traffic. So you can say, for example, this user here is allowed to upload to a file server in the data center, but I'm going to scan the files that they upload for viruses, or I am going to scan the files they upload with what's called a sandbox, which allows us to validate that there's no zero-day threats. I can do DLP and say that the stuff they're downloading from an internal web server, is it compliant with my data leak policies based on the posture of the device and the identity of the user? So tons of flexibility there to kind of scan what's happening on these internal connections.
Right. Is it worth talking about how access is sometimes anchored to IPs and how we deal with that? Because that comes up a lot as well when we're going through these conversations.
It does. You're kind of skipping ahead in the agenda.
I am, sorry.
Can you save that from when we talk about internet access?
I can. Yeah, absolutely.
Perfect.
So I think then the other piece that comes up often is there's a lot of organizations that look at third parties and contractors. So currently today they're issuing them VPN agents, or sometimes they've even got their own VPN agents that they're having access into the environment. So can we talk a little bit about how we manage that and how we're able to do that without putting an agent on their device?
Absolutely. So everything we've talked about thus far has been based on putting an agent on a managed device and having it broker access through. But as Simon mentioned, the traditional methods for managing third-party and contractor access are not great. Either you own the laptop and you control the posture of that device and the security of that device because you patch it, etc. And then you have to ship the laptop to this guy, and he, when he wants to access your network, has to use your laptop. That's not a great scenario. It's really not agile at all. It's expensive, etc. The second option is that you give them your VPN client and you install it here, and then they access your network via your VPN client. But again, not optimal, because now you're having a device that you don't control up here, VPNing into your network to access everything. And frankly, once they're on the network, they can see everything in most cases. And that's a device you can't really fully trust. So that's not a great option either. And so what Access has done is really spent a tremendous amount of effort innovating in the agentless access space. And so what that means is that these devices up here, whether the third parties, contractors, or some other kind of business partner, they connect to my cloud using a web portal. They authenticate themselves against your directory, again, Azure AD, Okta, IDP, Ping, etc. And once they're authenticated, they're going to get a list of all the apps that they can access. And everything I've shown here at the bottom is available agentlessly. So whether it's RDP or VNC, Secure Shell, web-based applications, SQL Server, and Git repositories, all of that can be accessed without an agent for these particular users. And we do that in a couple ways. For things like RDP and SSH, we have the option to do it through the web browser, fully encapsulated, or we have the option for these guys to use native clients. And this is really powerful, where a contractor can sign into my cloud, get approved. He can download a desktop launcher file for RDP and then connect to my cloud using RDP natively, and then have me connect to the RDP server on the back end and route that traffic, route that screen and those clicks back and forth. So you get the experience of a full native client like you were on VPN, but you're physically terminating your connection at the edge of my cloud. So I get full enforcement and visibility. And that's kind of the second point that I want to talk about, is that because these sessions are all terminated at my cloud, even the native ones, 3389 or port 22 for SSH, I now have full visibility to what's inside. I don't need a special key to be privy to what's happening in the SSH session, because this contractor is secure shelled to my cloud, and then my cloud secure shelled to the backend server. So everything that happens in the middle here, that's in the clear. And so what this allows me to do is for SSH to give you session logging of every command that's executed for web access, even though it's encrypted on the front end and encrypted on the back end with TLS. I can see in the middle, so I can give you a list of every URL that they access while they're in that session. So incredible visibility there, and also for things like RDP, incredible control. So maybe my backend server has no restrictions on things like file transfers, printing, clipboard access, but maybe I don't want this contractor here to have those things. Well, I can enforce controls here at my front end of the cloud to restrict those things, and then the backend server's policy never gets reflected up to the internet. So now I can say, based on who the user is, should they be allowed to have clipboard access or file transfer access, etc. So incredible improvements to visibility and enforcement. And of course, all that can be audited as well.
So there's two things to go from here, Ryan. Do you want to cover M&A first, or IoT and OT? Do you have a preference?
I have no preference.
Okay, so why don't we cover IoT and OT, just because it's on the same page without us having to change. Let's cover that bit first, because there's a lot of people that we work with in mining or manufacturing, or even, if we look at some of the cities that we work with where they're connecting into their waterworks environments, et cetera, et cetera. How can we go and facilitate that, and how do we enable them to do that easily as well?
Yeah, so I think there's two main use cases around IoT and OT. And the more prevalent one in our experience is around providing secure access. And it really ties into this third-party angle up here. And what we can do in a true Purdue security model, where you have your production IT network, and then you have a DMZ between your production and your true OT environment, and then you have your OT network over here where the actual devices, whatever those are, manufacturing, you mentioned waterworks stuff, valves and sensors or whatever. That's where all this stuff lives in a proper Purdue model. And so what we can do is we can put our connector, maybe with the right size pen, put our connector over here and have him access outbound to my cloud as well. And when we do that with a pretty arrow, what that does is that gives us a second way to broker access in. And so now I can set up, using the agentless access for these contractors or third parties, a way for them to get into the things in this DMZ directly, or based on firewall rules here, potentially to get into things in the OT network itself. But I'm doing that without punching any inbound holes through this firewall. Again, maintaining a zero attack surface and high security of the environment. And we see this a lot where in this environment, typically there's a lot of jump hosts that have access to things back here. Providing secure RDP access to this bastion host is definitely an easy thing to do. In some cases, customers will actually get rid of the bastion host altogether and just provide access to the backend things directly through the agentless web. And of course, for your staff, you can provide any access to anything because they'll have the agent on their device. And if they're on the network down here, no problem. We can have them connect directly to here and get access to these things, so they don't need to bounce off the cloud and come back. The second use case here is around internet security for these devices. So sometimes these things need to reach out, especially in the DMZ, we find this a lot. They need to reach out and get like Windows patches or something. And so again, we can build a connection either directly from this firewall tunneled through here or from this firewall out and using routing to allow the hosts in here to send their internet traffic to my cloud. And then we can perform all of this internet security stuff based on where the traffic is coming from and create a policy that's quite restrictive to allow them only to do the things they need to do and reduce the risk that somehow somebody clicks a link on this Bastion host and downloads something that's going to compromise the OT environment. So that OT internet security is also a big deal. And the same can be true. You mentioned IoT as well. If you've got, printers or security cameras or whatever here that need access to the internet, we can forward that through that secure tunnel as well. And again, apply all that security to those things.
Is it worth adding in there, Ryan, how we can do that with branch locations? We've got them positioned nicely over on the left, and how we're able to do that without having to put a connector in the environment?
Yeah, absolutely. That's a good point. So whatever WAN edge device you have here, as long as it can build IPsec tunnels outbound, we can set up redundant IPsec tunnels to our cloud such that anything in this branch, again, printers, security cameras, whatever the heck you need from here that needs to reach the internet, can traverse this tunnel, be subject to proper access policy and security policy, and go out to the internet. So you're able to apply those policies universally. And we also support the ability for things in this branch to use the IPsec tunnel to reach back into your data center network as well and access things there.
Great. So I think another area to cover would be mergers and acquisitions, not only from a risk perspective, but also just from a how do we do it as cheaply and as quickly as possible, right? There's a lot of organizations out there that bring people in, they don't want to have to merge the networks, or they don't want to, they're worried about what's going to come along with an acquisition. I think it's actually, one of the stats out there is 27% of acquisitions bring along malware, once they're brought in. So can we talk about how we're able to go and facilitate not only secure access, but how we make that cheaper and quicker?
Yeah, absolutely. So, I mean, to touch on speed first, I think it's important to kind of back up into how this would normally be accomplished with traditional tech. And the normal way you'd accomplish this is you'd take your data center and the acquired company's data center, and you'd put a network link between them and make them into one big network. The challenge with that is a few things. One, very typically, we're all using the same private RFC 1918 address space. So I've got my 10.0.xxx here, and I've got the same 10.0 space over here. So in order to just bridge these networks together, I need to readdress a bunch of these systems in the backend that are going to be linked. So that's a very lengthy effort. I've talked to customers for whom that process, depending on the size of the acquisition, can take at minimum months and often years. So that's not great. The other security challenge with acquisitions is even if you won the IP addressing lottery and you didn't have any overlapping stuff, you can't just necessarily link these things. You have to start linking your directory together as well and creating one logical active directory, which also creates a bunch of security risk. And of course, once you've linked the networks, anything here can talk to anything here, and that presents a bunch of malware and infection risk. So with the problem statement in hand, how can Atmos help here? And basically, there's two components to this. One is that because we're brokering access here at our cloud, these networks can actually have the same address space. And I can request intranet.mycompany.com and be routed to this web location here. And I can access staff.company2.com and be redirected to this web server here. Even if they have the same IP address on both sides, my cloud knows to route one this way and one this way just based on the name of the thing I'm requesting, which is incredibly powerful. It means that from a time to value perspective, I don't need to worry about ever integrating these networks. I can provide access to things in both environments day one. And I can do that with two separate IDPs as well. So I can have my AD over here and the acquired company's Okta over here, both linked to my cloud, so that the acquired users can log in with their Okta credentials directly. And we don't need to create accounts for them in my AD over here or link the two ADs together again, which is a huge risk. So that ability to kind of day one drop in a software device, which is we call a connector. It's a lightweight VM. You can drop this into the acquired company's network. You can link over here to their Okta environment, and you can provide agentless access the same way we did for contractors and third parties. You can provide agentless access to your acquired users to reach certain select resources inside your environment that are going to help them learn about the acquisition and maybe start accessing new tools, whether those are payroll tools or intranet or benefits or ERP or whatever. But you can also, by dropping this connector in, give your managed users the ability to start accessing systems and applications in the acquired company's environment, which is valuable for starting to assess what are you looking at from an integration perspective. And you can do that without sacrificing access to your own environment. So this user can be logged in to applications in both environments and frankly in cloud environments at the same time. And all of that can happen seamlessly and simultaneously. So you're not stuck disconnecting and reconnecting to different VPNs all day in order to make that work.
So why don't we take a step back here, and why don't we look at how we also secure internet access and SaaS traffic, Ryan? So
Sure.
Coming back to the initial drawing,
Yeah. So basically, what's cool, and I mentioned this at the top, we have one data pipeline, one data path for all traffic. And so we use the same exact components of who's the user, what is the posture of their device, and what does access policy say in order to control what users are be able to do on the internet. And that's, again, using these controls over here, things like virus filtering and malware filtering, URL filtering. So what sites are they allowed to visit or not visit based on my policy? We can decrypt their traffic completely, and we can look inside that traffic for threats. We can use inline CASB to enforce what actions are they allowed to take on the websites that they're visiting. Maybe you want them to be able to download things from Dropbox in case somebody shares a Dropbox link with them, but you don't want them to be uploading things to Dropbox. Well, inline CASB is a great way to do that. We can also use sandboxing here, which I mentioned before. This is a really powerful tool. Sandboxing is not just scanning for threats by hash. Sandboxing is going to take any file we've never seen before, and we don't know whether it's safe or not, and we're going to what's called detonate that. We're going to take it while your user thinks the download is still running. The download is just going to slow down. We're going to take that file. We're going to send it off to another location. We're going to run it on a Windows system as though it was the user's system and see what it does. We're going to look at the network traffic, any files it drops, registry entries it makes, etc. And we're going to make a decision on whether that's risky or not. And if it's not risky, the user's download just speeds up and they get to finish their transaction. If it is risky, we kill the session before the file is ever finished. So incredibly powerful tool here. And then the other thing that SSL Decrypt enables is these DLP policies, the ability to look at files that users are transferring back and forth and assess whether they're compliant with your policy based on file names, file sizes, file contents. We can look inside for certain strings or patterns, things that look like personally identifiable information or file names or paths or email addresses or social security numbers or whatever, credit cards. We can scan for any of that stuff in the files that are being transferred and apply your controls and policy based on those. So it's an incredibly powerful stack of things we can do. And we can do that whether that user is working from home or from anywhere, airport, Starbucks, doesn't matter. We can do that whether your user is in a branch location via these IPsec tunnels. And we can do that for traffic coming from your data center, web server going out here to reach for updates, or as we mentioned before, things in your OT environment trying to reach out to the internet. All of that traffic can be enforced by this entire stack here.
So why don't we talk about global locations, right? That's one of the other things that comes up quite often is, I've got something over in Singapore, or I've got users, all over the US, UK, etc. How do we go and manage that? And how is it different to how some of the other SSE providers do that?
Sure, we can absolutely talk about that. The idea here is there's really a couple of ways that you can build out a platform like this. And one way, which a lot of the major providers in this space have taken, is to build your own data centers. So they've built their own physical locations with their own physical servers in a bunch of locations globally in places that they believe are optimal for users. Now, that's really challenging to scale, and it's very slow. If I need a new location because I've got a customer that has users in that space, it takes months and months to procure the data center, procure the hardware, et cetera. The other approach is to take what was an on-prem firewall and just virtualize it. I'm just going to put my virtual firewall in AWS or in Azure or in GCP. But again, that's challenging because it basically extends your existing network up into the cloud provider, up into the SSE provider's network, and it gives you actually more attack surface globally. So if you want to enable users in London to access your data center in the US here, now you have exposure through some cloud provider in London with a virtual firewall instance physically running in that cloud. Our approach is, we think, quite different and pretty powerful. We run inside all of the major cloud providers, and we can spin up one of these points of presence in under 2 hours. It's all done through infrastructure as code. So the power of that means that regardless of what region you have a user in, if it's too far for them to reach to the closest point of presence that we have today, we can just create a new one. And we did that recently for a customer that had users in South Africa. We spun up a POP in Johannesburg one afternoon just to take care of those users. So we have over 300 on-ramps into our cloud globally that allow users to reach one of these points of presence in one of these locations. And you don't have to notify us or pre-configure that there are users coming from that location. One guy could be on vacation in Dubai to go play golf or whatever, and he's going to connect to a point of presence in the Middle East rather than needing to backhaul to some place that's physically close to you. So that's really powerful for global access.
So that kind of leads to the next piece then, Ryan, is, what's the user experience like? This is something that we get asked a lot. How does that work? What's the flow look like? How do we see this information, etc.? Do you think that it's worth showing the platform here so that people can get an idea of what that experience is like, especially around, third-party access, agentless access, because that's a big one that's often asked?
I do think it's worth doing that, but I realized that we forgot to come back to that source anchored traffic question. So I want to finish that first, and then I'll switch gears. So let me set up the problem statement for those who don't know the term source anchored traffic. The problem statement is that a lot of SaaS providers out here on the internet, whether it's someone like a Microsoft 365 or Salesforce.com, or some specialty ones, maybe you've got an HR company that's doing some work for you, they want to reduce their risk. And so rather than allowing connections from the internet as a whole to reach them, they want to lock down that traffic, secure it, so that only connections coming from your firewall to that SaaS provider will be allowed. Any other connections can just be dropped summarily, and they don't have to look at them. And that increases the security because they're not exposing your data to potential attackers in, Russia or wherever. The challenge is that when you go to an architecture like this, you're now coming from my cloud. So when you egress after all of these controls, you're coming from my cloud, and that doesn't look like your network. And frankly, it's also a challenge for even not my cloud. You've got a user working from home. Traditionally, to access those apps, they would have to VPN in, hairpin through the firewall, and then go out here. So it's not great that certain SaaS apps you need to be on VPN to access. So we deal with that with something that's really flexible, which is part of our URL filtering. When a user connects here and asks for that SaaS app, we can define where they're going to egress from in order to give you a dedicated address or address space to give your SaaS provider. So what we see commonly is that users will come here and then their traffic will get routed through a cloud access point, a connector in a cloud location near to the SaaS app, and then we go directly to the SaaS app from that location. That accomplishes what the SaaS provider wants here because it's a very limited address space egressing from, say, this Azure environment, but also helps this user because they've now got always on connectivity. They're not needing to turn on the VPN in order to reach that location. And you can anchor traffic through any connector that you want. So you can have different connectors in different cloud providers based on the thing that you're trying to access, or in different data centers based on the thing you're trying to access as well. So super flexible there.
So should we pivot over to the platform so that people can get an idea of what that looks like now?
Yep. Let me share a different screen here.
Hey, while you're pulling that up, Ryan, there was a question that came in.
Mm-hmm.
Question is, how long does this take to deploy?
The answer is always it depends, but we do something pretty cool and very powerful called a 29-minute challenge, where we can basically go from having nothing working in your environment to deploying a connector, provisioning application access, and accessing it through this agentless portal here in 29 minutes or less. So it's really great. So what I'm showing you here first is the agentless user experience. So this would be what your third party would see, or your contractor, or frankly, an employee on a BYOD device from home. And you can see I've got a bunch of applications defined here. The purple ones are web apps. I've also got some gray ones here, which are SSH applications, and then some RDP as well. And I like to start by demoing web. This is something, web apps are subtly complex. But what I've done here is I've taken this Access website name, which is what I created inside my platform, and I'm starting to tokenize the URLs underneath it inside here. So I'm rewriting the URLs in real time between my desktop machine, the connector, which is running in the cloud, and the website. And I'm able to access this as though I was on the regular internet. But all of the access is being routed through me. And so I've got all of these different links that I can click on. What you'll see, if, for example, if I go out to the customer support portal here, even when that link goes outside of the website. So here we've got support portal, which is actually ultimately linking out to a Salesforce instance, is still being encapsulated by my rewrite engine. And what's really powerful, if we get out of this menu here for a second, is that the performance is not impacted at all by being routed through here. I can stream live video through this engine and scrub through it seamlessly to get access to whatever I want. And one of the common applications we see actually for this platform is around accessing like network video recorders remotely for contractors. Similarly, I'll show SSH as well. Again, I talked about being able to use a native client for SSH. I'll just show it in the web browser because it's easier to demo. I've preloaded the credentials in my cloud, and this is super valuable for contractor-based access, where you don't want to give your contractor the access to all of the back-end credentials in case you move on from that contract and you don't want to replace everything. But I can run commands in here. I can look at the password file. I can look at the protocols file maybe. So whatever I do here, it all works and seamlessly as though I was just connected via regular SSH. I can even transfer files just by dragging and dropping them into this window, assuming the policy allows that. And I can do that for all kinds of SSH sessions in different tabs all at the same time. I'll also show you from this other portal what RDP looks like. So I can click here. Again, the credentials are pre-stored, and I can download the launcher or in the browser. And again, if I'm in the browser, it looks and behaves just like real RDP, but it's running entirely in the web browser. And here we can see my domain controller. I'm able to access it as though I was logged in locally without any issues. So real flexibility there in terms of this secure remote access for applications. And what I see as tiles on this screen is completely filtered by my access policy. So I can't see anything I shouldn't be allowed to do. And in fact, if I was connected to something and my access got revoked, immediately that session would be severed. So I can't continue to access something just because I was already logged in. So I think that's a good first place to start in terms of the user experience. In terms of the management experience, there's a couple things that I'll highlight here. The first is, if we come and refresh this dashboard, because it's going to be a little bit out of date now, what you'll notice is that this gives us a great place to see what's been happening. So here we can see that I accessed the Access website private application and this secure shell application. And if I click in here, you see exactly what I did. What did I click on while I was connected to that session, which is really powerful. We can also see here all the commands that I issued via SSH, doing a change directory to Etsy, looking at passwords, protocols, and hosts, and then bailing out. So incredible visibility and control through that. And for all the regular logs, those are here too under exploration. So without needing that command by command detail, you'll be able to see all of the web traffic from me in the last hour and where I was going, plus all the agentless traffic. So here you can see my SSH session that we just did, but we can also go back and we can see various web apps and web locations that I've been accessing, YouTube, etc. So tremendous visibility here, and you can filter this by whatever you want, and even things that are not exact. So if your user doesn't know the exact URL, no problem. I can just search for API here, and any host that has something that looks like API in the name is going to pop up in my results. So it's very easy to find things. The other view you have, which is incredibly powerful, and I'm going to change where I'm demoing this from. Change where I'm demoing this from so we can get a better view of it, is our user experience view. So once this loads the other tenant, we can take a look at what we're seeing in terms of actual real world performance. There's not much this morning, it seems, but see if we can extend out and get a little bit more. Real world performance between your users and the applications that they're accessing. So here we can see, for example, Jeff having a rough time this morning from his computer. It took 358 milliseconds to get to Ashburn, where our point of presence was. But then from there, it was just 2 milliseconds to get to the application. So if this user phoned in and complained, we know that it's a problem with his internet connection. In fact, if I hover over this, we can see his internet connection seems quite variable, as low as 36 milliseconds and as high as almost 1 second. But let's find a better short example here. Let's see if we've got something really short. We don't have anything really, really short, but here's Dan accessing something. And again, from his place here on the West Coast, 44 milliseconds to reach Ashburn, and then a millisecond and 0 milliseconds. So really good detail. And again, doesn't matter what protocol. These are all web-based, but they could be Active Directory, they could be whatever they're accessing, and we're going to instrument that data for you. So really cool there. I'll show one last thing here, which I think is really relevant to folks if they're actually day-to-day admin on the platform, which is that it's one single integrated policy. So I've got a first rule here is blocking traffic coming from high-risk nations to any private application. But then I've also got rules here that say full-time employees that are on a trusted device. These are my baseline postures for my trusted device types. They're able to access a mixture of things. And what's powerful here is, again, one policy. So I'm locking down some public websites here with this web category. I'm locking down some SaaS applications using the Box and the Dropbox managed profiles. And I'm locking down these private applications using this all employee apps tag. And the tag is kind of one of the last things that I want to highlight. What's really powerful with that is that it creates a buffer, a virtual connection between the applications you define and the policies you create. So you can use a group from AD over here as a source, like we did, all full-time employees from Okta. And then you can use a tag here that says, should be able to access all employee apps. And now if I want to create a new application and I want to allocate it to all employees, it's as simple as creating that application, going through the process here, and at the end, assigning the application tag all employee apps. And as soon as I do that, effectively, this new application that I've defined on the platform gets sucked into the policy. I don't need to do the work of then manually provisioning access. So it cuts down the time that it takes to manage the platform. So that's probably a good summary of kind of user and admin experience. Simon, is there anything that I didn't cover that you would have covered?
No, I think we went a little bit long, actually. So
sorry.
That's all right. I'm going to turn it over to Drew, because I said that we'd be finished around 45. So just a couple of minutes over there, but I think that covers everything.
You guys did a great job. Thanks. There's a couple questions that came in the chat and then a couple others in Q&A. So let's get through these here quick. First one is Access is one of the vendors that does not charge for bandwidth usage. So how do you charge for bandwidth usage, or how do you charge for this?
Yeah, great question. So we charge on a per license basis. So we don't charge for bandwidth usage at all. So what we do is one person would have a license. So for example, let's say Ryan, and that license would extend to all his devices that he would have. So if he's got, cell phone, iPad, MacBook, also maybe he's got a HP computer or whatever. So all of those would be included under that one license. And it's charged on a per license basis per year, per user per year.
Perfect. Clean and simple. What technology do you typically see being able to be removed with this solution?
Okay. So usually the first one that people are looking at is either VPN, Citrix, some VDI use cases, things like that. That's usually what they're trying to do first. Sometimes would be going and helping remove, maybe they've got something in place that they are backhauling all their traffic and running it through filtering. So maybe that could be your firewalls that they've got sitting in the data for egressing traffic. I'm trying to think what else. Ryan, what else have I missed there?
I think that's a pretty good summary. I mean, I think where we see it commonly is existing remote access solutions for third parties can get consolidated. And so sometimes you have a second VPN, or you have like a Citrix solution or remote desktop thing or something like that. VDI commonly. So a lot of those things that you used to use for secure third-party remote access get collapsed completely. And then you covered, reduction in firewall spending, complexity, reduction in VPN, et cetera.
Yeah. Sometimes also, existing SSE vendors, if someone's gone with one of the first generation SSE vendors in the past. So, maybe like a Zscaler or Palo or something like that, Drew.
Perfect. Simplifying and likely end up saving the folks, the resources that manage those things mentions time, right?
Yeah, absolutely.
We got one or two more here. So how would this compare to a typical VPN, meaning user account changes in mid-flight?
So I think I covered that briefly during the session, and maybe the question was earlier, but it doesn't matter. Basically, if access to that particular application, whether it's through the agent or through the agentless portal, if their policy changes during the connection, we will adjust dynamically. So let's say, hypothetically, I'm connected to backend SAP, and I've got my laptop open and I'm working. And as an employee, I get terminated and my policy gets revoked. That SAP connection gets severed immediately. I don't get to leave that connection open just because I was already authenticated. So traditional VPN, once you're on, and it's very difficult. Where with this approach, you can sever just one application access and leave everything else live just based on policy changes. It's really powerful.
Awesome. One more, and I think we'll kind of round this out here. So for, I think most that are on here, vested into the technology marketplace, most know that there's a lot of SASE vendors out there now. You touched on this during the prezo, but I think this is a good way to round things out. What do you gentlemen see as main differentiators for access security as opposed to competitors?
Yeah. So I think one of the main reasons people go to Axis or look at Axis first is our agentless capability. It is standout in comparison to the rest of the market. In fact, the rest of the market are trying to catch up on that side of things. So it is very, very good. So that side, and also private application traffic. So getting rid of those VPNs, that side of the fence is, we are definitely leading the market on that side. The other differentiator I would say is ease of use and deployment. There's lots of scenarios where we've heard people say they've bought a solution but haven't been able to get it fully deployed because they've got niche use cases that still need to have the VPN in place or things like that. So it's causing them frustration. And then just one platform. Our platform is built as one platform, as opposed to one being purchased, one being built, then trying to integrate them together. And on paper, with the marketing side, it looks great, but on the technology side, it still doesn't work as well as it should do.
Awesome. Thanks for that. I think it's kind of a closing remark here. Ryan, Simon, thank you so much for this. This was very, very informative and powerful. There were some folks that joined here a little bit late. We're going to get this recording sent out to everybody for those that missed the first part and for others to review later on as well. So Ryan and Simon, thanks again. Appreciate it much.
Yeah, thanks for having us.
Pleasure.
Kim, any closing remarks from you?
Nope, I was just going to say everything that you just said. Thanks for everyone that joined. And then I think a few people had some troubles logging on, so we'll get that figured out too. So it'll make it a little easier for next time.
Thanks for everybody joining. Have a good rest of your day.
Thank you.
Thanks. Take care.